Good day, everyone. Um, my name is Emmanuel. I am the developer. I'm a software engineer and also a blockchain engineer. So I will be taking us into what Arbitrum is, and we'll be going deep down into the source writing. I'll be showing you the way you're going to be installing your environment variables, all that part that is needed for the development of Arbitrum. So let me give you a few intro about this program. This is dApps over apps, and in collaboration with them, I wrote this book to guide us into or to give us an insight into Arbitrum, building with Arbitrum, and all you need to know about starting is building a smart contract with Arbitrum. So I'll go deep. I'll start with the first on the list, which is to talk about all the things that are going to. So this book, during this video, I have a concept that you're familiar with most of the concept. So what I'll be doing basically is just the environmental setup and the deep explanation of the programming language and explaining it, though it's well detailed, but then I give some explanation on what's going on. So we'll start by looking into um let's start by looking into what we're supposed to have in our system before running it, and we go to chapter 8 and practical application and case study, and we're taking from chapter 21. And firstly, before you need to build it, we're going to need Rust. We'll be needing VS Code as usual for IDE, but you can use any suitable IDE you prefer. But I'll be using VS Code. I just find it's lightweight and easier to use. But you can use anyone, either ranging from Vim to Nano or any other IDE you prefer. So you'll be using extensions like Rust Analyzer, Error Lens, even better Tomon and Crit. Um, so this is great. This is even better Tomon. So you can install all this, and so this doesn't. If you're unable to install it, that can't stop you from running the program, as this is just an helpful tool in writing and debugging. So they do not affect your development in any way. So you are going to be needing test tokens or faucets for deploying of our smart contract. So head on to MetaMask, create an account, switch to the tested account, and it basically is very simple. It's just a step-by-step guide which they are going to follow you through. And then when you're done, you switch to the tested account, and you'll be depositing your account with this website. So go to uh, https and arbitrum.faucet.dev. You're able to get a list of tokens you can use, for deploying, and you can claim them. These are other ones also you can use. Okay, so this is me, getting a token and deploying it, or receiving a token from the L2 Faucet website. So I think if you have about zero point 0.5, you are good to go. You're going to be able to deploy and make changes. Okay, so let's look at what we're going to be doing, the installation of Rust. So there's a command called cargo install force, cargo stylus, and cargo stylus check. We need to install that command for us to be able to run it smoothly and effectively. So we'll be using a command called cargo stylus, and that what we're going to be using for the deploying and for the checking of errors. So this is what you should get when you have installed it finished. So it should show successful installed cargo stylus check, and for the second part, you need to run the command called rostop target add wasn't 32 unknown 30 unknown unknown. So it's a way to convert your build to make sure that you're using wasn't build up targets. That's the way we do it in Rust, there's a long documentation on why the crate is called wasn't 32 unknown, and but that's not really the scope of what we're discussing. And the next thing you need to do, you need to verify your installation by doing the cargo stylus help. So the cargo stylus help gives a list of commands, which some of them we are going to be using. It has a command like cargo new, cargo export ABI. We have a command like cache, check, active, deploy, and deploy, trace, verify, cgen, and help. So we'll be using commands like new, export ABI, check, and deploy to do for this building or this building phase. Okay, so firstly, first, what you need to do in developing a stylus program is you need to run the command cargo stylus new and then the name of the project you are running. So this is like a way to give a startup file or startup folder for you to work with, and it installs all those template code just like you're using for those that are coming from the Next or from the React or from the you know any other programming language. You see, there's a way you can give a boilerplate code. So this cargo stylus they give a boilerplate code, so you don't need to start afresh. Have most of those dependencies you're going to be using installed already, and then you'll be able to go. So that is installed already. We have number two. We're going to start developing our program. So we're going to touch in our cargo.toml file, the source slash main.rs, the source slash and lib.rs. So what the cargo.toml is like a package manager for Rust. Just like how we have for TypeScript or JavaScript, we have what we call the package.json for managing packages and for installing packages for running scripts. We have the cargo.toml for managing packages in Rust. So we have the source slash main.rs. So this is a binary file. Is we the reason why you don't get files like that in something like TypeScript or JavaScript is because it's a compiled language and it doesn't need the main entry. It's an interpreted language, so it doesn't need that. So languages that are compiled time languages or lower level languages need an entry point, just like something like I think C plus plus, C, Python to some extent, even though it's not really a but that's not the point. But the point is that Rust needs a file called source domain for entry point into the program, and we have the lib file which is for to define library for functions that you've been needing, and basically it's just like when you want to write in maybe TypeScript and then you have the app file that then all other components are being called inside the app file. So we see the app file as the main entry and the other component that is calling it as the other component as the library, since you can write all the needs of code that you need, and all you just have to do is just call all the component or the necessary component inside the main file or inside the app.jsx or tsx file. Okay, so now let's dive deep. So this is a good structure of how the cargo.toml look like, and you can see this is the packet. We have the name, which is going to give the name, just like how we have in can give a version. This is not really needed, but if you want to maybe have you having different version, you can add that to it. So this is an edition, 2021 edition. Dependencies, we have dependencies like alloy primitive, we have alloy soul types, we have mini alloy, we have stylus SDK, we have X, we have .env. So these are the dependencies we're going to be using, and some of them we're going to be talking about. It. We have Tokyo. Tokyo is a web framework, you know, for Rust, the web framework for Rust. So we'll be using that also. We have ITAS. So that's what we'll be using for that. But we'll not really use that since that's not the scope of the video. And we have others like features, for exporting APIs. So this was basically in the book. I wrote some explanation into what it's about, like the dependencies, explain the dependencies. So this dependency provides primitive types used in Ethereum like chains like such as address and U256. So what this means is that it provides the list of chains and commands that we're going to be using, the types that we'll be using in in uh, in deploying. Yes. So basically, you can go through this and you can find out what we are going to be needing. We have the bin file, which is have the name decentralized block, the name of the binary. When built, the executable file will be called decentralized block. Okay, just like it. So the bin file or the binary file will be called decentralized block. If you check the folder part where it's going to be downloaded to. Okay, so this is the main.rs file. This is the entry point, like I said. So conditionally compile the program without a main function unless export API is enabled. This is typically used for smart contracts where the standard entry point is not required. So here we are not going to be using the main entry point because using main is like it's going to need to import a lot of dependencies that might not be needed, and we just need something to directly the bound. So it doesn't really need the main function. So we have a way. This is called a macro. This is a macro to remove the need of main function and then just give an export API. So the if the export API is enabled, this function acts as the entry point, and after the entry point, it prints the API for smart contracts using the Stylus hello print API function, and the API is compiled by the license type of NIT or app and the Solidity compiler, the Pragma Solidity. So that's what it's used to. That's what it's being compiled to, and this is not explanation into that. We have done our explanation already. So now let's go into the main topic, the leap file. You can see here we have to say, oh, no entry file here, since we'll not be needing any. And let's look at the next one. So we have what we call the global allocator. So this is a set up a global allocator using the mini alloc for efficient memory management in the smart contract. So the thing about Arbitrum is that it's trying to reduce size, so you can't push a certain level of size to the database in Arbitrum. So all this feature, all this the macros are used to reduce the size of the reduce the size of the exporting and API and everything. So global locator, so static alloc, mini alloc, and then we have the import crate. So what you do is that it imports the alloc crate to enable alloc if allocation in no standard environment. So we are going to see a lot of packages that we want to use, like we talked about, the alloy primitive, the dependency that was downloaded. You see that it has types. So these are types that we'll be using, like address, uint, block, console, storage vec, and storage string. So now let's start. Define the storage structure for the block smart contract using the soul storage macro. So this is a way to like create some kind of structure, or some people call it class, some people call it objects. depending on the language you come from. So in Rust it's called structs to some extent, yeah. So we are going to determine that, and this structure contains mapping to store information such as the the number of posts and post content, user token balance, referrals, and more. Okay, so solidity and soul storage. So pub struct blocks. This is like the name of the structure we'll be creating, and we're creating a variable called the post count. So what it does is that it tracks the numbers of posts by user, and we have the posts creation time. We have it to track the last post creation created or created, the last post creation time per user. We have the token balance to track tokens of each user. We have the mapping. We have the referral. We have the referral count. So this app tracks referrals per user. We have the post content, which stores each post by ID. We have the post categories. So this stores the categories of each post by post ID. We have post comment, so it stores comment for each post ID. We have the UIT post donation, which has post donation, which stores the donation for each post IDs. So we're going to declare the okay. So declare that blog is contract with the following external method. So we are going to implement a blog smart contract. So the smart contract allows users to purchase tokens by adding specified amount to their wallet. So firstly, this is a function that we're going to be creating, and what the function does is that it helps you, purchase token for a certain amount of money you want to purchase, and then purchase it. So we have the let. We created a variable called the token balance assessor, and we are using self. When we talk about self is talking about the block struct, which is this. So self is just like when you are using this, it's almost similar to, so depending on the language you're coming from. Like JavaScript, what we call self is called this, and it's just like saying this dot token balances. So but now it's called self dot token balances, and then we are using the setter to set the user address. Then once that is set, we use the current balance. We get the current balance by using the token assessor dot get. So it gets us the token balance, and when we get the token balance, we set the balance, with the current balance, and we are adding the amount that we are passing it to. I hope this is really clear. Let me come again. So I created another variable, and gets the token balance assessor, which we did here. So after getting the balance assessor, I took the balance assessor and added the current balance with the new amount that you are adding to it. So it increases the balance. So this function allows users to a post. Create okay. This this function allows users to create a new post by spending tokens. It checks if the user has enough tokens, and if at least 5 seconds have passed since their last period. So if valid, it updates the post count, stores the post content, and categories, and deducts the token. So update the last post creation time and emit a successful post creation event. So that is what that function do at on the top part. It's mostly the handling of tokens, or buying of tokens, and handling the way tokens should be tracked. We have the create post. So we have the create post, which is the user address, their the address, the storage address, and okay. So we have it to create a post, which is taking in a value of user address, it's taking a value of the the category and the content. So what it's going to do is that there's a variable that I created called token balance. So what it does is that it gets the token balance from that user ID, and I'm, I'm saying that let post price equals to maybe one token, and so you just do a check. You do a check, if check. So this is an if check in Rust. So you do an if check. If token balance is greater than or equals to post price, and we did a variable of last creation, and we say self dot post creation, the post creation time, and we added the user ID. We did a 5 seconds interval, and you can see the time stop, and then we give a condition that if 15 seconds from last post, you know greater. So we have this 5 parts to do it, and let me go through. I think I made a lot of documentation about this. Okay, so the function updates the leaderboard by increasing the referral count for the user. So it emits is an event to log the updated referral count. So this is the update leaderboard to update you know the referral count. We have this function updates the leaderboard by increasing the referral count for the user. So it emits an event to log the updated referral counts. So what they do next is that this functions allows users to add comment to the specified posts. It's okay. So we're going to take this one out first, and moving down, you can see that we have the comments. Comment is stored in a vector associated with the post ID, and the long message is generated. Okay, so this is it. So we have the donate to posts, which is to help users to donate to other posts. You can see it just takes in the user ID that you want to donate to, and the amount you want to donate to the user ID. That's another. So pub function gets. So we have a function for get post count for, and we have a get token balance for, and looking at you. to getting all this ready, you're going to take it from this first part, and we have the function to get posts and comments. We have the function to get donation for all the posts, and that's what we're going to do basically. There's a lot of like explanation for doing that. Like the first one, I give an example. We'll be going deep into the second one. So this is the creation of the posts. Okay, this is well done. And so what you're going to be doing next is you're going to do a creation. You're going to do a creation, and you can just go through all these parts. Once you go through these parts, you'll be able to understand what you want to do, and you want to. Okay, so okay, so the let's go through it again. We have the source storage for storing or for creating structs or class for structures for the database or for storing the data. We have the number three, the smart contract method. We are going to be using the token purchase function, which takes in an address and an amount that you want to get. We have the create posts, which takes in self, like I said, and what we mean by and mute self means that is changeable. So this is a reference to a changeable self, like it's making the self changeable. So that is why we can make adjustment or change the value of user address and all that, because we are making it changeable. Mute makes things changeable. We're taking a reference. This ampersand means we're taking a reference of mute self. So that's just what it is. And then the create post function is central to blocks functionality. It requires users to spend token to create posts and checks that. So it checks that the user has enough tokens and at least 5 seconds has passed since their last post. So if both checks pass, the post count is updated, the post content is stored, and tokens are deducted, and an event is emitted to log the post creation. So the mechanism is crucial for initiative users to contribute content while maintaining a balance between post frequency and token usage. So that is what that does. I tried to make a 5 seconds pass, to give this post frequency and token usage. We have the refer users. We have a referral system that lets user refer others to the blog, increasing their referral count and updating the leader board accordingly. So this creates a network of effective effects, encouraging users to promote the platform. We have a function called comment on posts. So What it does is that it allows users to comment on specific posts which are stored in a storage vec. So the contract dynamically grew the vector to store in new comments and logs each comment with the message. So that's what it do and does. I've already explained about that in previous video. We have the donate to post. So a function donate to post, and this just helps us donate tokens to the post. And we have view method. This is like a lot of view method to just fetch some particular data, you know, pertaining to it. So since that is done, we have done a lot and we have explained, the code base and how it's going to flow. So let's see how we're going to run it. So firstly, we're going to run the command called cargo stylus check. And so what we're going to use that cargo stylus check is to check if that command can be deployed and activated and shared successfully. So it does the check before you can push it. So if it fails, you might see an error message like this, wasn't caused by binary exports. You can see other errors, but if it was successful, you're sure gonna be getting this, success message. And we have also another thing we're going to be doing. We're going to be running cargo cargo stylus check. You can see what they did. You need to have Docker installed and be running Docker for this to work. So you need to have Docker. You can see this is the steps. It's gonna start downloading it in your Docker file, and yeah, basically, and then start running the cargo stylus check. Okay, so this is a successful completion of the cargo stylus check. Okay, that's not it. Okay, this is it. um so after it was we done checking it, we have the cargo stylus deploy, which we use in deploying the smart contracts to of the sharing. So with this, we have successfully written and set up our environment, variable. We have installed all that thing that we need, both with uh both with our code and our code base, what we need with our faucet, and a deep explanation on the code and running it. And basically, that's just all you need to know to run a code and deploy it anyway. Thank you so much for listening. And the next one, you can just, if you have any question, we can reach out to the team, dApps over apps, and you can read through the book because it's well explanatory. And you can just check through about other topics there, and you can still reach out to us. If there's still more other things I want to work. Thank you so much for your time, and do have a great day.